Hello, let us solve some MCQ on vector function and its derivative. So the first question, r is given in this tuple. So r we can write t square I plus sin t j plus e power t k. Then dr dt will be component wise differentiation, that is 2ti plus cos tj plus e power tk. So option A is correct. Next, the second question, rt equal to this one, then dr dt is always, now we know that dr dt is equal to the vector v, which is velocity vector, and this is always tangent to the path or curve traced by the object. Okay, so option A is correct because dr dt represents the instantaneous velocity. It points in the direction of motion at any point on the curve. Next question, RT is this, so modulus of dr dt. Now dr dt is minus sin t I plus cos t j plus k. So modulus will be square root of sin square t plus cos square t plus 1. That is, if we calculate, this is 1 plus 1 equals to root t. So option B is correct. Now for the next question, RT is this. So velocity means, actually r if is this tuple, then you can write in this way I j k. Then the velocity vector is always the derivative of r, that is dr dt, and this is equal to again component wise derivative. So 3t square I plus e power tj plus 1 by t k. Also we can write this again in the tuple, that is in the first bracket 3t square e power t and 1 by t. This is the method. So option A is correct in this case. Now next question, the acceleration vector is the derivative of, actually you know that if r is the position vector, then v, the velocity vector, is dr dt, and acceleration is equal to d2r dt2, that is the derivative of velocity, and since v equal to dr dt, we can write this as d2r dt2. So if r is this, then we have to find acceleration vector. So we know that a vector is the d2r dt2, that is d dt of d2r dt2, and d2r dt2 is the first order derivative. So a I plus 2b tj, that is equals to, first case is 0 and second is 2bj. So if you see, option B is correct because we can write 2bj as 0i plus 2bj. Next question, r is this vector, that is t square I plus t cube j. So dr dt will be again component wise derivative, that is 2t I and 3t square j, which again we can write in tuple. At t equal to 1, this is 2 comma 3. So option A is correct. For the next question, r is this vector, so we have to calculate d2r dt2. Now dr dt is e power ti minus e power minus tj. Again d2r dt2 equal to e power ti and plus e power minus tj. This will be e power minus tj. You can check. So option B is correct. And next question, number 9, we have to calculate the velocity vector. Velocity vector is dr dt. So it will be, if we write component wise, this will be minus 2 sin 2t and 2 cos 2t. So option A is correct. Next question, we have to calculate the speed at v. So we have to calculate first the velocity and then we have to take the absolute value. V equal to dr dt, then component wise it is 1, 2t, 3t square, and if we take at the point t equal to 1, then this is 1, 2 and 3. Now we need speed, that is absolute value of v, which is 1 square plus 2 square plus 3 square. This is equals to 1 plus 4 plus 9, that is 14. So option A is correct. Now the derivative of rt always gives velocity. So option B is correct because v equal to dr dt. Next question, r equal to this, then the acceleration vector is, we know that d2r dt2, that is d dt of dr dt, and dr dt is actually minus a omega sine omega t I plus a cos a omega cos omega t j. Then again derivative will give us minus a omega square cos omega t I minus a omega square sin omega t j. That is, we can take minus omega square outside, a cos omega t I plus b sin omega t j. So the option is, that is actually minus omega square r. R is the given vector. Since the minus, so it will be radially inward because of this minus. Next question. If rt equal to this one, then vt equal to the velocity vector, that is dr dt. So it will be 2t I and 3t square j. So we can write in as tuple 2t 3t square. That is the option A is correct. For the question number 14, rt is this and we need to find speed, and we know that speed is the absolute value of the velocity vector. So this is equal to 1 cos t modulus, that is 1 square plus cos square t. So option A is correct. Next question, rt equal to this one. We know that r is written as xi plus yj plus zk, and if you compare with the given vector, then x equal to cos t, y equal to sin t, and then x square plus y square equal to 1. So this is a circle of radius 1, option B. If rt equal to e power t e power minus t, then absolute value of velocity is absolute value of dr dt, that is absolute value of e power t minus e power minus t. So if you take the absolute, then e power t square plus e power minus t whole square, that is equal to e power 2t plus e power minus 2t. So option B is correct. Next question, we have to find the acceleration vector, that is a vector which is equal to dv dt and it is equal to d2r dt2. So d dt of v is dr dt. Dr dt is 1 2t 3t square, that is 0 to 60. So option B is correct. Rt equal to this one, then the curve traced is r equal to a cos t I plus b sin t j. And if you compare these as the position vector xi plus yj, then you can see that x equal to a cos t and y equal to b sin t. Then x by a equal to cos t and y by b equal to sin t. Then x square by a square plus y square by b square you can write, or cos square t plus sin square t equal to 1. We all know that. So if we put the value of cos square and cos and sin, then x square by a square plus y square by b square equal to 1. So this is a ellipse. So the curve traced is ellipse. Next question, rt is this, the velocity vector is dr dt. This is 1 by t and minus 1 by t square. So option A is correct. Next, the derivative of a constant vector function is, so let us take r as a constant vector, that is suppose r equal to ai plus bj plus ck, where abc are constant. Then dr dt will be equal to 0i plus 0j plus 0k, so 0 vector. If you want to see more video like this, then like and subscribe and share with your friends.